Hello everybody, and welcome to exercise 5 on page 21 of the workbook. Let's read this problem together. So the volume of a sample of an ideal gas being held at a constant temperature is given by V equals F of P equals 120 over P liters, where P is the pressure of the gas sample in atmospheres. And they would like us to do two calculations to find F of 6 and F prime of 6, and then to interpret those two quantities in the context of the problem. Okay, so before we do any calculations, I'd like to just draw a rough graph so we can get our bearings here. Okay, so we've got a function that has P as its input variable, that's a pressure in atmospheres, and then V is our output variable, that's a volume in liters. And if you were to graph this function, 120 over P, what you would discover is that it's decreasing, so it kind of has that sort of a shape. If you think about that, that makes sense because if you had a sample of gas in a cylinder or something, if you increase the pressure on that gas, its volume should decrease. It compresses it. You can see that behavior in the function that we're looking at. All right, so let's start with our calculation of F of 6. Okay, so that's algebraically asking us to take the number 6 and to substitute it into this formula, 120 over P. So we'll get 120 over 6. That works out to be 20. Then the question is, what's the meaning of that calculation that we just did? Okay, well there, it helps to think about the meaning of the two variables. So we substituted a 6 in. That's an input variable, which is a pressure in our problem. And then outputs of our function are volumes. So we could look at that calculation and notice that it's just telling us that when we have a pressure of 6 atmospheres, we have a volume of 20 liters. So the volume of the gas is 20 liters. When the pressure is 6 atmospheres. Okay, that would be a brief explanation just of that first calculation that we did. All right, we could, just thinking graphically about what we did, we took a value of pressure, 6, substituted it in, and discovered that the volume that went with it was 20. Okay, so we're really just talking about one point on this volume curve when we do that. We are ready then to look at the second calculation, F prime of 6. This is going to be a little bit more work, so we need to calculate the derivative of F at 6. Remember that we have a formula for that. Okay, it looked like the limit as h goes to 0 of f of a plus h, and our a is 6, minus f of a, f of 6 over h. Okay, so we need to do those calculations. Let's clear a little clutter away here. And starting with f of 6 plus h, we need to take 6 plus h and substitute it into our function. So everywhere that we see a p is going to go a 6 plus h. Right, so if we do that, we're going to get 120 over 6 plus h. And then we come to f of 6. Okay, that's asking us to take 6 and plug it in for p. Okay, over h. Now, one thing to notice here is that 120 over 6, that number we've already seen one time before. That's the 20 that we saw up here when we calculated f of 6. And then the question becomes, how do we calculate this limit that's sitting in front of us? Okay, well, first of all, could we get away with just substituting h equals 0 in? Because after all, h is approaching 0. Could we do the limit by just substituting 0 in for h? Unfortunately, we can't because of the fact that we've got an h in the denominator. If we did that, we would get a 0 in the denominator. And so this is a situation that we've been in quite a few times. We need to simplify before we can substitute in the h equals 0. All right, so to do that, I'd like to think about common denominators. So we've got a 120 over 6 plus h. We're subtracting a 20. I'd like to get a common denominator of 6 plus h between those two terms. All right, so the 120 over 6 plus h, we'll leave that the way it is. The 20, we will take that and multiply it by 6 plus h over 6 plus h. Okay, you can think of 20 as just being 20 over 1. It's also a fraction, and all of this is being divided by h. Okay, so continuing to the next step here, we've got a 120 over 6 plus h, and if we multiply these two fractions here and here, we are going to get 20 times 6 plus h in the top, and just 6 plus h times 1 in the bottom. Okay, and notice we have a common denominator now. These 6 plus h's match, so we can put those two fractions in the numerator together. Okay, so we're going to get 120 minus 20 times 6 plus h over common denominator of 6 plus h divided by, and then kind of thinking ahead to what we're going to be doing a little bit later in this problem, the h that you see in the denominator, we can write that as a fraction in its own right by putting it over 1. H is the same as h over 1. Okay, we'll use that in a minute here. Okay, and now we've got a negative 20. We're going to take that and distribute it through. And so let's see, that's going to turn our numerator into a negative 20 times 6. That's a negative 120. And then minus 20 times h, that's minus 20h over 6 plus h, and that's over h over 1. Okay, and then notice one nice thing happens here. Those 120s go away, and now what we're really doing is dividing two fractions. And so next step for me here is going to be to take the negative 20h over 6 plus h. Notice that we're dividing by the fraction h over 1. That's the same as multiplying by the reciprocal. Okay, so we can rewrite that as negative 20h over 6 plus h times 1 over h. Okay, moving to the next step here. Go ahead and multiply those two fractions. So this fraction times that fraction, we can just multiply straight across. Okay, we're going to get that. And notice now we are in a situation where we can cancel those h's. And so all that's left to take the limit of here is negative 20 over 6 plus h. Okay, so if we substitute 0 in for the h, we're just going to get negative 20 over 6 plus 0, which is 6. And if we get a number for that, that's going to be negative 3.33. Okay, wow, that was quite a bit of work. But we do have an answer for the f prime of 6. Now the question is, what does that mean? Okay, what are the units of that? Well, remember what the derivative represents graphically. It's the slope of a tangent line. And so we could go back to our picture at the top here and draw in a tangent line, and its slope is f prime of 6, negative 3.33. And so the units of that slope would have to be units of rise over run, which means that we're going to be getting liters per atmosphere. If we look at the units on our axes. And so those units kind of tell us how we want to explain the meaning of this statement. Notice that that's a rate of change of volume with respect to pressure, telling us how fast the volume is decreasing, basically. Okay, so as an explanation, we could say maybe something like this. So this means that at a pressure of 6 atmospheres, and that's kind of our starting point. I'm getting that 6 from up here, f prime of 6. The volume of the sample is decreasing by 3.3 liters for every atmosphere that the pressure increases. Okay, so that f prime of 6 is just telling us basically how fast the volume is going down relative to the pressure going up.